Namaste dosto. Imagine you have your favorite ice cream, a creamy scoop sitting perfectly atop a waffle cone. Now, if I asked you, what's the total volume of this combo? The cone plus the scoop, you might pause. But actually, this is a neat example of what we call volumes of composite figures or combined solids. When two or more simple solids join together, like a cone mounted over a cylinder, the total volume is simply the sum of each volume, as long as they don't overlap or leave gaps in between. For example, if we have a cone sitting on a cylinder, then the total volume equals the volume of the cylinder plus the volume of the cone. In math terms, you'd say V total equals V cylinder plus V cone. In real life and in problems, these combinations get interesting. We often see shapes made by joining a hemisphere and a cylinder, a cone and a hemisphere, or even a full cube with half a sphere attached. But to find their volumes correctly, we must carefully pick the right volume formulas for each shape and make sure the dimensions make sense for the parts that fit together. So whenever you tackle these composite solids, remember, break them down into known shapes, calculate each volume carefully, and then add them up. Areva, it's like putting the pieces of a puzzle together. Let's keep this in mind as we move further. Alright, friends, before we dive deeper, let's quickly refresh some fundamental volume formulas for basic solids. These are your building blocks. First, the cylinder. The volume of a cylinder equals pi times the radius squared times the height. In words, that's V equals pi r squared h, where r is the base radius and h is the height. Next, the cone. A cone's volume is exactly 1/3 of the cylinder's volume when they share the same base radius and height. So, V equals 1/3 pi r squared h. Now, the hemisphere, which is half a sphere, its volume is 2/3 pi r cubed. And for a full sphere, it's 4/3 pi r cubed. Don't forget cuboids and cubes. For a cuboid, volume is length times breadth times height, or V equals L times B times H. For a cube, with all edges equal, it's simply edge length cubed, or V equals a cubed. Keep these formulas handy. They are the tools for every volume problem, especially for combined solids. You'll see how these appear again and again. Let's look at how to use these formulas when multiple solids join to form a bigger shape. The key idea: when solids join neatly at their surfaces without overlapping or intersecting inside, the total volume is the sum of each individual volume. In other words, V total equals V1 plus V2, and so on up to Vn for n solids. However, it's very important that the dimensions you use for each solid match how it fits in the combined figure. For example, if a cylinder has a given height and a cone sits on top with its own height but the same base radius, use those exact dimensions for their volume calculations. Also, make sure all your units are consistent. If one solid size is in centimeters and the other in meters, convert before calculating. Otherwise, the total volume will be wrong. This addition principle is everywhere, like when you eat an ice cream with a cone plus a hemisphere scoop, or consider a water tank shaped as a cylinder capped by a hemisphere. The world loves combined solids. Now, what if instead of joining solids, you have one solid carved or hollowed out from another? Then you need to subtract volumes. This means the net volume is the bigger solid's volume minus the inner part's volume cut from it. Formula-wise, V net equals V outer minus V inner. Say you punch a cylindrical hole through a cuboid block. The volume left is the cuboid's volume minus the cylinder's volume taken out. This subtraction method is super useful in many fields. Packaging designs where cutouts are made, or structural engineering where cavities help reduce weight without losing strength. Always draw and understand the shapes before subtracting. The right volume will emerge only when you carefully apply subtraction. Okay, time for some calculations. Suppose we have a cylinder with a base radius of 7 centimeters and height 10 centimeters. On top of it sits a cone with the same base radius 7 centimeters but height 6 centimeters. Our total volume is volume of the cylinder plus volume of the cone. Step 1. Calculate the cylinder volume. That's pi times 7 squared times 10. 7 squared is 49. So 49 times 10 equals 490. So cylinder volume equals 490 times pi cubic centimeters. Step 2. Calculate the cone volume. Remember, cone volume is 1/3 pi r squared h. That's 1/3 times pi times 49 times 6. 49 times 6 equals 294. Divided by 3 equals 98. So cone volume equals 98 times pi cubic centimeters. Add them up. Total volume equals 490 pi plus 98 pi, which is 588 pi cubic centimeters. Numerically, pi is approximately 3.1416, so the total volume is about 1846.32 cubic centimeters. Imagine how much ice cream that is. Here's another example. A cuboid measuring 20 centimeters by 15 centimeters by 6 centimeters with a hemisphere of radius 7.5 centimeters placed perfectly on top. First, find the cuboid's volume, length times breadth times height. That's 20 times 15 times 6, which equals 1800 cubic centimeters. Next, the hemisphere volume, 2/3 times pi times radius cubed. Radius cubed means 7.5 times 7.5 times 7.5. That's 421.875. Multiply by 2/3 and pi. This works out to approximately 883.13 cubic centimeters for the hemisphere. So, total volume is 1800 plus 883.13, giving 2683.13 cubic centimeters. A perfect fancy box with a dome on top. Last example. Think of a sphere with radius 14 centimeters but with a cylindrical hole drilled right through its center. The cylinder has radius 7 centimeters and height 14 centimeters. It perfectly matches the sphere's diameter. The net volume equals the sphere's volume minus the cylindrical hole's volume. Sphere volume is 4/3 pi r cubed. 4/3 times pi times 14 cubed. 14 cubed is 2744. Multiply by pi and 4/3 to get approximately 11,494.04 cubic centimeters. Cylinder volume is pi times radius squared times height. Pi times 7 squared times 14. 7 squared is 49, times 14 is 686, times pi equals approximately 2156.28 cubic centimeters. Subtracting, net volume equals 11,494.04 minus 2156.28, which is 9,337.76 cubic centimeters. That's quite a hollow sphere now. Imagine the cool shapes engineers create with this technique. Let's quickly wrap up what we learned today. Remember these volume formulas. Cylinder volume is pi r squared h. Cone is 1/3 pi r squared h. Sphere is 4/3 pi r cubed. Hemisphere 2/3 pi r cubed. For combinations, add volumes when solids join without overlap. Total volume equals sum of each volume. When one solid is removed inside another, subtract volumes. Net volume equals outer volume minus inner volume. Always use accurate formulas with consistent units. Visualize the combined solids carefully so you pick the right dimensions for each part. And remember, exam problems often align dimensions to make calculations easier, like sharing the same radius across joint parts. So next time you see a compound solid, break it into pieces, find each volume, add or subtract as needed. Shabash. You've got this. Keep practicing, and these skills will help you solve tricky geometry and real-life problems with confidence. Happy calculating!